Hi, my name is Ricky De La Rosa, and today I'm going to be teaching you how to prove this trig identity. Alright, so let's read it out first. Sine squared x all over cosine squared x plus 3 cosine x plus 2 is equal to 1 minus cosine x all over 2 plus cosine x. Alright, well what are we going to do first, basically? What I like doing first is strategy number 1. Well, let's take a look at all our strategies first, and our identities right here, strategies. Well, simply, what I like doing first is strategy number 1, boiling it down to sines and cosines. But as you can see, it's already boiled down to sines and cosines. There's no cotangent, tangent, secant, or cosecants. So, we can't really do that. So what else can we do? Well, when I see a squared already, I'm already thinking Pythagorean identities, which is strategy number 5. Alright, well, let's manipulate this equation. We're going to subtract cosine on both sides, which will, at the end, give us sine squared x equals 1 minus cosine squared x. Now that we've proven this, we can replace sine squared x with 1 minus cosine squared x. So, let's go ahead and do that with our equation. Well, not our equation, because that would mean the whole thing, so basically just this factor. It's not this factor. What am I saying? Oh my god. This fraction. Now, all we did is simply replace the sine 2x with the 1 minus cosine squared x. Because we can do that. Because we proved it. Alright, and why did we do that, you ask? Well, we did that because we want to get as close to our end goal as we can along the way, those steps. You see, every step we take, every move we make, we want to make the left side be looking as similar as to the right side as possible. So at the end, when we get all the way to the bottom of the paper, our end goal can be our left side. Our left side can be our end goal because we're trying to prove this. So now, what can we do here? Well, I see a trinomial at the bottom. So, is it factorable? Well, let's try it out. Well, what do you know? It is factorable. Don't believe me? Well, let's FOIL it out. Cosine x times cosine x equals cosine squared x. Excuse me. Cosine x times 1 equals, well, cosine x. 2 times cosine x equals 2 cosine x. Well, when you add those up, that gives you 3 cosine x. And then simply, last but not least, 2 times 1 is 2. So, in fact, it is factorable. Well, we're getting closer to our end goal. We already see the cosine squared x plus 2. See, we already see it at the bottom. And we see a 1 minus cosine squared x and a 1 minus cosine x. Well, we're going to want to get rid of this somehow. What can we do? Oh, wait, I know. We can cancel this out with one of these. Well, let's try that out, see if it works. We were able to cancel out cosine x plus 1 with 1 minus cosine squared x. It did not cancel out all of our numerator because, well, it was squared. So therefore only 1 gets canceled out because the denominator part was not squared. So therefore only existing 1. Which will then leave us with 1 minus cosine x all over cosine x plus 2. Now, let's take a look at our end goal. Well, looking pretty similar, right? Except for the denominator. Oh, wait. Addition is commutative. And by that means that we can switch these or manipulate them, if you will, any way we want to. And by going off of that, we have now proven our trig identity. 1 minus cosine x all over 2 plus cosine x equals 1 minus cosine x all over 2 plus cosine x. And there you have it, folks. Your proven identity.